Hello everyone. Okay, today we're going to look at another problematic topic in additional math, which is called surds. This is one of the foundation topics that's learned in Sec 3 together with logarithm. So just like the logarithm video, as I mentioned, right, it is a problematic topic. Surds likewise is also a problematic topic. But also to remember that these surds or logarithm, while problematic, they will continue with you all the way until you graduate in secondary 4. So somehow or other you will still need to be able to understand them, okay? But the thing is that with practices just like algebra, you will get better and better each time round when you practice it. Okay, the question of why surds are so complicated is basically because that surds has square root, okay? And these square roots are actually things that they do not want you to evaluate them. So unlike the case where you have a calculator, I press square root, then I will be able to evaluate the answer, but they don't want you to do that. They want you to work with the surds term, which means the square root term, in such a way that, right, you need to be able to know how to simplify them. And the way to simplify them is always by looking at this thing called the common surds. Yeah, common surds. So if you hold by one rule, okay, which is, remember that whenever we want to simplify surds, we want to find this thing called the common surds. Then you will not have any problem. And when I say common surds, I mean to say that the number that is being square root, the whole number inside, is totally identical. Because if they are identical, they can be combined by addition or subtraction. Okay, so remember that. And let me point out a few problems to you of why you think surds is very difficult. So problem number one will be, you are very used to using the law in the forward direction. So for instance, square root 3, okay, times square root 3, you know that this will be just square root 3 times 3, which is equal to square root 9. Thereafter, this will become a 3. Right? So this is what I meant by forward direction. Because the rule was square root a times square root a or square root b is supposed to give you square root a times b. Right? This entire thing is square root then a times b. So this is a forward direction. But when you are simplifying surds term, a lot of times the number inside are not identical. They are not the same. So that's why you need to learn how to work backward to get them to be the same thing. So if you look at my example here, square root 80 for example, the thing to do is that if you are given a square root 80, by right you are supposed to understand how to do this, which is to break up into two numbers inside the square root. So the proportion of breaking up, right, will always be one number that can be square rooted. The other number will be as small as possible. So 16 times 5, right, is a good combination. You can use your calculator to try. So from there, right, I can split it into square root 16, square root 15. Notice that was the backward of the combination. Square root a times square root b will give you square root a times b. So this is the backward. Then after which, right, you will notice that the 16, which can be square rooted, can actually be changed into a 4. Then square root 5 will remain. So from here onwards, this will be the first step that will get you to the next step of combining into another term with square root 5. Okay, so remember, this is the property that we are using. But instead of asking you to combine, the question requires you to separate them. Problem number 2. Often you have to create common surds by simplifying to the smallest possible number. So this is the thing that you might not know. You have to combine surds with different number, but you do not know how to do this, or you didn't know that you need to do this. So in this example question, you can see that minus square root 11 minus square root 99 plus square root 44. So first thing first, 99, 44 are not numbers that you can square root. So even if you press a calculator, it's not going to help you. But the thing is that you will notice that 11 seems to be the common thing among all three, because all of them can be divided by 11. And as a result of that, I'm going to change my 99 to 9 times 11 instead, as well as a 44 to 4 times 11. So in the previous slide, while I say that the square root number should be the bigger one, then the other is the smaller one. Okay, but not always. Like in this case, I would think that the 11 will not be the smallest one, but I change it in such a way that everyone will eventually have a square root 11. So now if you split, okay, you will get square root 9 times square root 11. Square root 9 will be 3. Then square root 4 times square root 11. Square root 4 will be 2. Then we get 2 square root 11, 3 square root 11, and square root 11. So now, then we can actually simplify them to minus 2 square root 11. And exactly what happened here is this. Okay, the coefficient of square root 11, the things in front of square root 11, right, actually are the things that we can add and subtract from there. So from this step onwards, actually what I did was, I did a minus 1 square root 11, minus 3 square root 11, and then plus 2 square root 11. So minus 1 minus 3 will be minus 4, minus 4 plus 2 will be minus 2. Okay, so the number in front can be added if the square root is of the same number. Okay, so this is the fact that I'm using here. 3 square root a plus 2 square root a will be 5 square root a. Right, you can do that provided the square root is the same. It's a bit like 3x plus 2x is 5x. So the idea is actually the same. Okay, problem number 3 will be this. Question often will also need you to get into a specific form. So the thing is that once people see this, they are extremely fixated of thinking of the final answer. But I would say that you should not do that. That will be the last few things you will think about. But the first few things, in my opinion, is try to simplify and combine it as far as possible. Because if you are doing that, then eventually you will get to the point where the final expression will just come out. So you don't need to be too fixated of talking about how to get that at the start. So let me show you with this example. Okay, so the 3 simple steps in this example is number 1, you try to combine into a single term. Number 2, expand only when needed, don't need to do it too early. And number 3, rationalize the denominator after that. Okay, so I'm going to show you how to do this now. So first thing first is I got the 3 minus square root 3 with a bracket square. I will not expand this first. Okay, I will not expand this first. Let's try to combine into a single fraction. So which means to say that I will have a 3 minus square root 3 bracket square, the whole thing divided by 1. Okay, anything that don't have a fraction, right, is just over 1. Then we minus away 5 over 2 minus square root 3. So let's make it the same common denominator. So on the left side, I'll multiply 2 minus square root 3 top and bottom, and this is what I will get. So I'll get 2 minus square root 3. Then this is 3 minus square root 3 bracket square. And then I will get minus 5, right? So on the right side, there's a minus 5. The whole thing will be divided by 2 minus square root 3. So I will do this first. And now, coming to the part of expand only when needed. I think I need to expand now. Otherwise, I don't see that I'm getting the answer yet. So now I'm going to expand it. Let's expand the square first. So expanding the square bracket, I will get 2 minus square root 3. Okay, this part will be 9 minus 6 root 3 plus 3. Okay, then minus 5. Okay, this one is using the formula of a minus b is a square minus 2ab plus b square. Okay, then simplify this a bit. Okay, sorry, hang on. Okay, over 2 minus square root 3, then I will get 2 minus square root 3. Simplifying, I will get 12 minus 6 root 3 minus 5. The whole thing over 2 minus square root 3. Okay, something like that. Then after which, right, what we will do is that, right, you can see that most people will just do a removal method immediately. But for here, I can see that 12 minus 6 square root 3, there's a common factor of 6. So why not we try to do that first? So with that, okay, let me draw a line here. Let's continue here. Then you will see that it's actually 6 bracket 2 minus root 3 square minus 5 over 2 minus root 3. So can you now see that by doing this, I can avoid the problem of multiplying very big number? Okay, actually I don't have to do the 2 minus 12, 2 times 12, 2 times 6 or 6 root 3 and so on and so forth. So if I can avoid that, I will try to avoid that. So now, as you can see, I can apply the formula again. So this will become 6, 4 minus 4 root 3 plus 3. Okay, then after that minus 5 over 2 minus root 3. Okay, then after that you simplify into 7 minus 4 root 3. Then we will get, okay, let's do this. So 6 bracket 7 minus 4 root 3 minus 5 over 2 minus root 3. Okay, something like that. Then after which, right, if I continue, I'm going to continue on top. So from here, I will get 42 minus 24 root 3 minus 5 over 2 minus root 3. Then we will get, let's see, 37 minus 24 root 3 over 2 minus root 3. Then from here, right, what you need to do is that because I need to get a plus b root 3 at the end, right? So the last step will be, cannot have a denominator with such, we rationalize. So rationalize will be multiplied by the conjugate, 2 root 3 over 2 plus root 3. And then eventually you will be able to get the denominator to be 4 minus 3. Actually very surprising. 4 minus 3, 1. Then I don't need to care about the bottom already. Then the top part will be 37 minus 24 root 3. Then multiplied by 2 plus root 3. So expand, simplify, you will get the answer. Okay, I will not continue from here, but I hope at least by doing all these steps, it can get you a better understanding of the steps involved in order to achieve the final answer. So whenever possible, I think the golden rule will be try to simplify the surds as far as possible before moving on. Do not just multiply the thing in, or if let's say there's things that you can factorize, maybe you factorize first. So this will help you to do the question easier. So for math, right, as best as possible, try not to work with big number. Okay, I have an expression here to simplify. It's involving surds. So using the idea that we talked about so far, let's see how we can simplify this. Remember, the golden rule is common surd term. So we make sure the number inside is the same. So we look at 48, 12, and 27. If I were to change it, this is how it looks like. This one should be 16 times 3 plus square root 4 times 3 plus square root 9 times 3. Notice that one of the number can be square root, the other number is a common number 3 across all three of them. So I split it into 4 root 3 plus 2 root 3 plus, okay, sorry, this is a minus, just realized, minus 3 root 3. Okay, something like that. So now finally the final answer will be 4 plus 2 minus 3. 4 plus 2 will be 6. 6 minus 3 will be 3 root 3 is the answer. Okay, so you can see how making it to be the common term, common surds term is important. Because if you do that, then one part can be square root, I can simplify, take it out of the surds term, then I can combine into this manner, and then that will be the final answer. Okay, problem number 2. Okay, this question asks you to solve for the solution, putting in the exact form again, very tedious. So let's see how to do this. Okay, first of all, right, when you look at x root 7 and x root 2, right, these are the terms that need to be put together. So just like when we talk about 2x is equal to 3x plus 2, you notice that you need to bring the 3x to the other side to put the x together. So even if it's surds, right, nothing changed, it's just a number. Square root of a number is just a number. So don't think of it too complicated. It's not a different thing altogether, it's the same thing. So the first thing I'm going to do will be, right, I'm going to move the x squared 2 to the left side. So I will get this. Something like that. Okay, then from here you factorize. The only thing you have to factorize is because unlike the case where we have a 2 and 3, they can be added. So these are unlike surds, so they cannot be added together. Then after that, you divide. Of course, eventually to get the final answer, let's rationalize this. So I'm going to multiply by a square root 7 plus square root 2. Multiplied by a square root 7 plus square root 2. So once again, we use the formula of this. We use the formula of a plus b, a minus b to be equals to a squared minus b squared to simplify this. So 7 square root 7 bracket square will be 7, right? So let's write it down. This will be 7. Then the other one will be a 2. And the numerator will be square root 32 multiplied by square root 7 plus square root 2. Okay, then once again, if you were to expand this, okay, before you do that, maybe we see whether we can simplify square root 32 first. So look at it, right? I think square root 32 can be broken up into 16 and 2. So let's try to do that. Huh? So instead of multiplying that, we will get square root 16 times 2, okay, multiplied by square root 7 plus square root 2, the whole thing divided by 5. Okay, then this will become a 4 square root 2, square root 7 plus square root 2 over 5. So now last step will be have to multiply thing inside. We will then actually get 8 plus 4 square root 14 over 5. So in this case, we can conclude that A is 8, B is 4. Okay, just compare back with the original expansion here. Okay, so you can see that I did not direct my answer to that, but all I did was I tried to combine, simplify as much as possible. So no need to think too hard about the form that they want you to get. That will be the last few things that you look at, not the first few things. First few things is that think about how you're going to solve the question, how you're going to get a solution. So that's the thing you think about. Okay, problem number 3. This is a common question you get to see. Application question. Right circular cylinder has a volume of 6 plus 2 root 3 bracket pi and a base radius of 1 plus root 3. So find its height in the form of a plus b root 3, where a and b are integer. So I will say this is surds, but however, think about what happens if let's say you're going to find this without thinking of this is a surds problem. So first thing I will do is that I will draw a right circular cone, cylinder, like this. And then this is my height, which I want to find. This is a question mark. Okay, then in this question, I'm given a volume is 6 plus 2 root 3 pi cm cube. Okay, this is my volume. And the base radius is given as 1 plus root 3. Then they ask you to find the height. Okay, remember that cylinder, to find the volume is take the base area times the height. So now I want to find the height. I should be doing a volume over base area. Volume over base area to find my height. Okay, base area in this case, because it's a circle, so it's pi r square. So we're going to put it in now. 6 plus 2 root 3. Then with the pi outside, then the bottom will be pi r square. So the r square will be 1 plus root 3 bracket square. Notice that in this case, the pi that maybe initially you were thinking, wow, got pi, how to do it? Now we can actually remove the pi. So we are getting a 6 plus 2 root 3. And the denominator, you can expand it. So after you expand it, once again use a square plus 2ab plus b square. You will get 1 plus 1 plus 2 root 3, okay, plus 3. Square root 3 bracket square will be 3. Then from here, we will get the expression of 6 plus 2 root 3 over 4 plus 2 root 3. And at this step, take a step back. Can I simplify this? Yes. So this is how it looks like. Then you cancel away the 2. And now, finally, let's rationalize the expression. So I'm going to multiply a 2 minus root 3 and a 2 minus root 3. And finally, the denominator will become 4 minus root 3 bracket square, which is, once again, 1. Okay, so the denominator is 1. Then the numerator will be 3 plus root 3 times 2 minus root 3. So 3 times 2 first, we get a 6. Then 3 times minus root 3, we'll get minus 3 root 3. Root 3 times 2, we get plus 2 root 3. And root 3 times root 3, we will get a minus 3. So the final answer will be 3 minus root 3. Okay, so A is 1, B is minus 1. Okay, so just a problem like that. And I will say that this problem basically summarizes all the rules that you learn in surds. And this is also the way the question will be asked in the exam as well. Okay, that will be my last problem for today. I hope by going through the different problems that you face and helping you to understand that this problem, actually there's a way to overcome it. So you will be able to look at the question from a different perspective, and then when you relearn surds again, it is not as difficult as you think it is. Okay, thank you very much for watching, and once again, to reach out to everyone. Okay, if you like the video, please help me to share around and help me to subscribe. So this will help us to move forward to build more video for the rest of you. Okay, thank you very much. Look forward to see you in our next video.